This is the Junior Maths Challenge from 2022. I haven't actually seen the mark scheme for this. I'm just kind of predicting that everything that I've done is right. There's no way of checking it, but I am a god, so it's all right. Question number one, which of these has the greatest value? I mean, you literally just sit here and you work out each one, and you work out that this one at the end is the biggest one. Hopefully we all got that. Question number two, I mean, you can just draw it so that, like, this one is only one box away, so you draw this way, and then this way, and this way, and then this way, and this way. Of course, I have the advantage that I can just copy-paste the image flipped, and of course we read the answer as this. But yeah, if you ever see a mirror question, just get out some paper and draw it, and do the best you can. And you should eventually end up with the answer. Think of any number, add 5, blah, blah, what is the resulting number? The 100% best way of doing these questions, especially in Junior Maths Challenge and especially at the start of the paper, is you just try each answer. So you take 10, you add 5 is 15, multiply by 2 is 30, add 10 is 40, divide by 2 is 20, subtract our number 10 for 20, add 3 is 23. 23 isn't one of the answers, so it's not that. And then you go to B and so on. That's 100% the best way of doing it. If you want to do it with actual maths, you start with x, you add 5, you multiply that by 2, which involves multiplying both bits by 2. You add 10, so I put brackets, you add 10. At this point, I decided to start simplifying things, so multiply 2 by x and 2 by 5 is that. Simplify it. Divide by 2 comes next. That involves dividing each of these things by 2, so we get this. Subtract your original thing, which is subtract x, cancel the x's, and then add 3, and we get 13. So x must have been 13. When you're doing this whole trial and error, like obviously if you want to do this, fine. When you're doing the whole trial and error thing, it might be best to start from the right and work left, because the people who write these questions like to troll you. And for any questions that trying the answers is the most effective tactic available, they'll know you'll try left to right. And so just to stall you, they'll put the answer towards the end. So it might be best to try right to left. Anyway, question number 4. Hopefully you recognize that 0.6 is 3/5. And as soon as you recognize that, the answer is very easy to get. Question number 5. Try each of these in turn. So 1 over 1 is of course an integer. It's the integer 1. 11 over 2 is not an integer because it's 5.5. 111 over 3 is an integer. And if you're going into a math challenge, you should know that divisibility by 3 check. I mean, you can get out a bus stop and you can just test it. But if the digits of a number add up to a multiple of 3, then the number itself is divisible by 3. So 1 plus 1 plus 1 is 3, which is a multiple of 3. So this is definitely going to be an integer. I think it's 37 in the end. So moving on to the next one. Of course, this is an odd number, so you can't divide it by 4. You can only divide even numbers by 4 to get integers. So that's not 1. And of course, anything divided by 5 either has to end in a 0 or a 5 to be an integer, so that's not going to work either. Again, bus stops would be fine, they'd get you decimals. And so 2 of them are integers. Question number 6. So this is a square, which means it has a right angle in it, 90 degrees. These are equilateral triangles, which means their angles are 60 degrees. This is a circle, or a point, so this angle here is 360. Take away all of these 3, which I can work out very quickly, so this is 150. Now this here, this triangle is isosceles because this length is the same as this one, which means these 2 angles are the same, which means 180 minus 150 is 30. That's how many degrees are left in this triangle. The 2 angles are the same, so 30 divided by 2 to share them equally gives me 15. 3. Kind of an interesting question this. A super effective tactic in math challenges to make stuff up. So let's just make up that 1 kilo of oranges contain 200 grams of vitamin C. Let's just make that up. Which means that if the same weight of kiwis have 2.5 times as much vitamin C, then that means 1 kilo of kiwis have 500 grams of vitamin C, because we times that by 2.5. Times by 2 is 400, half it is 100, add it on to get 500. So 1 kilo of kiwis contains 500 grams of vitamin C in my made-up world. What weight of kiwi fruit contains the same amount as 1 kg of oranges? So what weight of kiwi fruit do I need to contain 200 grams of vitamin C? Well, if I just divide this by 5, I get that 0.2 kilos has 100 grams, and then times it by 2 to get 0.4 kilos has 200 grams. And the answer will be 400 grams, or 0.4 kilos. Obviously, it's both the same. Today is Thursday. What day will it be in 100 days' time? Well, 7 times 14 is 98. So in 14 weeks, exactly, it will also be Thursday. And there are 2 days left over. So on the 99th day, it will be Friday, the next day, and on the 100th day, it will be Saturday. You could have also just done 100 divided by 7 to find 2 remainder and then counted forward 2 days. Yeah, either way. How many squares of any size can be seen in the diagram? So I can obviously see one really big square, 3 by 3. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9 smaller squares. I'll list those there. So the 9 1 by 1 squares. These 2 by 2 squares are these squares here. So one of them there, one here, one here, and one here. And then thinking about the smaller squares, well, there's clearly 9 of them in here. Again, I can see those. But I can also see a few littler 2 by 2 squares, exactly the same as we saw before, and there's still going to be 4 of those. And I think that's all I can see. You add them all together and you get 27. Question number 10, half of a quarter. Again, this is exactly the same as what I was saying before. Just try each answer. Half, so working backwards, I guess, an eighth of a number, well, an eighth of 14 is a horrible decimal or a fraction, so I'm already dubious of that, though maybe it would work. I think one of the things that we need to do is actually find out what we're aiming for. So let's actually do this. Half times a quarter plus an eighth. Making all the denominators the same, 4 eighths plus 2 eighths plus 1 eighth, that's going to be 7 eighths. So actually the fact that this is that 14 divided by 8 is a fraction is not too bad because I'm aiming for a fraction. But yeah, just trying each of these in turn would be the best thing. Otherwise, you can set up this algebra. An eighth, a half of a quarter of an eighth of a number is equal to this, which is that. Multiply all this out. 2 by 8, 4 times 8 is 64. You can bring this one up, multiply by 8 over 8 to make this, and then of course x just has to be 56, because 56 lots of 1 over 64 is 56 64ths. But again, trying the answers would have been the best way, I think, rather than setting up algebra, unless you're very comfortable with algebra, in which case that's the fastest way, which it is for me. 9 of the numbers here are put in 2 groups. The sum of each numbers is a multiple of 4. What's the largest number could be left out? So it seems natural to just add up all these numbers first. I happen to know that's 55, so that saved me a bit of time because I didn't actually have to add them together. And now I'm going to split these numbers up. I'm going to remove one number and then split up the rest of them such that both numbers add up to a multiple of 4. Now, they currently all add up to an odd number. For 2 groups to add up to a multiple of 4, both groups together must also be even and a multiple of 4. So I need to remove a number from this such that I get a multiple of 4. Now, if I remove 9, the reason I'm removing from the top down is because the question asks what's the largest number that could be left out. So if I removed 1 and it worked, that's great, but then I would have to try 2 because it's looking for the largest. So let's work from the top down. Let's remove 9. Now, actually, the fact that 9 isn't in the answer list means that what I'm about to do is pointless. But the point is, I need to take away an odd number because I need to get to a multiple of 4. So let's take away 9. Now, can I make 2 groups add up to 46 that are both multiples of 4? Well, no, because 46 isn't a multiple of 4. So instead, take away 7, and that is a multiple of 4. That's 4 times 12. But just to double check that these numbers can be split in such a way that make 2 multiples of 4, I'll actually just do it, and I found that set. There might be more, I don't know, but I thought it'd be safe to actually test. And it turns out I can remove a 7 and make 2 groups. This one, they both add up to 24, so that's fine. Question 12. Paint is half full, or a pot of paint is half full, weighs this. Pot of paint is quarter full, it weighs that. So a pot plus half of the paint is 5.8 kilos, and a pot plus a quarter of the paint is 3.1. We can code this, right? If I call pots X and paint Y, then I get these 2 equations here, and hopefully at least the year 8s who are watching will know how to deal with a simultaneous equation. I can just sort of take these away from each other. I can say, what's this whole thing in like a column? Taken away this one, well, x times x, take away x, nothing. This take away this is 0.25y, and this take away this is that. If I times everything by 4 here, because this is the same as a quarter y, times everything by 4, and we learn that the total paint should be 10.8 kilos. Now, of course, if the pots plus half the paint is this, half the paint is 5.4, because the full paint is 10.8, so that means x is 0.4. So half the paint, that's 5.4. 5.4, this take away 5.4 is 0.4, and so we learn that the pot is this, and if we add those together to get the pots plus all the paint is 11.2. Yeah, there are probably other ways to do that if you haven't learned simultaneous equations, but for me, that's definitely the easiest way to do that. Okay, squares, side length 1, 2, 3, 4, and 5. Let's just work out the area. So this area is clearly 1, 1 times 1. This area is 2 times 2, which is 4. But I'll just mark the shaded area is 3 because there's an area of 1 in the middle which we take away. So we've got an area of 4 here. Take away this 1 gives us an area of 3 going around the outside. Likewise, this next one, the whole area is 9, but we're going to take away 3, take away 1 to get 5. This area is 16, take away 5, take away 3, take away 1 is 7. Hopefully you see a pattern. The next area is 25, take away all these things and you get 9. As a side note, really interesting to prove that you always just end up with the consecutive odd numbers when you do this. If you just keep doing this, then these numbers just keep going 11, 13, 15 and so on. Kind of interesting. Anyway, what percentage of the outer square is shaded? Well, the outer square is 25 big and the shaded is 7 plus 3. So we're going to have 7 plus 3 over 25. As a percentage, percentages are over 100, so times this by 4 to get 40 over 100, so 40%. Question number 14, quite an interesting question. There's a ring with people sitting around it, and the 13th person in a row, so the first person, second person, third person, and so on. Number 13 is opposite number 35. So what I did was I counted back 12 people until I got to 1, and that means the first person is opposite 35, count back 12, is 23. So the first person is opposite 23. And likewise, the second person is opposite 24, and the last person is opposite 22. Though I don't know what the last person, their number is yet. If I draw a line straight through 1 and 23, because they're opposites, I split the ring into 2 perfect pieces. Now, all I need to do is count how many kids are on this side of the circle, and that must equal the number of kids on this side, because this defines halfway along, because I know 1 is opposite 23. So there will, from 2 to 22, I struggle with this kind of thing, but there are 21 numbers between 2 and 22. If you take 1 away from both, it's easier to think how many numbers are there from 1 to 21, or 21 of them. So there are 21 people here, which means there are 21 people here. Add 21 up from the 24th person, and you actually only get to 44. Again, I initially thought, oh, 45, but then 45 wasn't there. And then I realized again, like 2 plus 21 isn't 22. It's because you're already counting this kid anyway. So you only get to 24, which is a bit weird. So 44. I struggle with that kind of idea. I remember being at an interview at Oxford and face palming on that just because I was a bit stressed as well, and I just couldn't count. Anyway, question number 15. We all have regrets. Here, so one way to deal with lots of division happening is to treat some of it as division and some of it as fractions, and then I can just do KFC. So 6 divided by 8 tenths is the same as 6 over 1 times 10 eighths. Just doing KFC, keep the first one, well 6 is just 6 over 1, change the sign, flip the second one over to make 60 over 8, and then again I can treat the 4 as 4 over 1 and then just do more KFC here. So change the sign, flip this one over, times it along to get 32 over 60, and then one more time, that's a 2 over 1, change the sign, flip the fraction over, and we get 120 over 32, halve both for 60 over 16, halve again, and we get 15 over 4. Question number 16. So we've got a lot of equilateral triangles here, it looks like. So this triangle is 2, 2, 2, this one is 5, 5, 5, and this one is 8, 8, 8. So if this is 2, 2, 2, and this is length 5 here, because this is 5, that means this is 3, and so is this one. These are 2s, of course, and that also means these are 8s. So that's everything I've got so far. I'm looking for the perimeter P, Q, R, S, T, V. So I'm looking for this weird jagged shape here. Now, of course, I can just add 5 plus 3 plus 3 plus 8 plus 8, and then all I'm missing is these 2 lengths here, this little bit here and this little bit here. Now, it's actually interesting that you don't actually need to know what each of those lengths are, which makes sense because you could just move this triangle up and down this length without changing the problem itself. But if this whole length is 8, because this length is 8, and this length is 2, then I know that this length plus this one is 6. So those 2 lengths added together are 6, because the whole thing is 8 and this is 2. I don't know what each of them are, but I know both of them together are 6. And now I can just say, well, 5 plus 3 plus 3 plus the 6, which is both those bits, plus 8 plus 8 is going to be my total perimeter, and we get our answer, which is 33. 17. 2 people playing a game. Player starts with 10 counters. So let's start with 10 each, and at the end we have A with 40 and B with 16. Now, if one player wins 3 counters and the other player loses 1 for every game that's played, that means every single time a game is played, 2 counters are gained within the total. So right now the total is 20. Whoever at the start, because each have 10, whoever wins the next game, the total will be 22. Because one person will go up by 3 and the other will go down by 1. Doesn't matter which way around that is, the total is going to be 2 more. So if the total increases by 2, no matter who wins each game, then we see here the total is increased by 36. Which means if 2 counters are gained per game, 18 games must have been played to get to this total here. Now we just have to figure out how many each person won of those 18, and trial and error is probably the best way to go here. I actually got it first time just by guessing 12 and 6. If A won 12 and lost 6, she gains 3 counters 12 times and lost a counter 6 times. 12 times 3 is 36, take away 6 is 30, and she gains 30 overall, which matches perfectly. It also matches perfectly for B, you can test that. But yeah, just some trial and error at the end there works. And you sort of always get a feel to split it up nice and evenly, so I split it up 2/3 to 1/3. But anyway, the answer is 12. 18, the diagram shows a parallelogram. We just need to know our rules for angles here. In a parallelogram, opposite angles are equal, so this thing equals this thing. Not very helpful right now. But also, angles that are next to each other, co-interior angles, add up to 180. So this plus this is 180. And so actually this makes 5x minus 70, add 70 both sides, divide by 5, x is 50, and you can put that 50 into the first one you came up with. 2 times 50 is 100, take away 30 is 70. Add 50 to both sides, divide by 4, and we get y is 30, and that will be our answer. 19. Start of the day had 3 times as many apples as pears, so the ratio of apples to pears is 3 to 1. So you might not have 3 apples, 1 pear, you might have 6 apples, 2 pears, or 9 apples, 3 pears, or 12 apples, 4 pears, and so on. It's always got to be a whole number, because I'm assuming that's how this question works. By the end of the day, after eating 5 apples and not eating any pears, they now have twice as many pears as apples. So actually, we can just run with each of these guesses here and take away 5 from the apples and leave the pears alone and see which one is ratio 1 to 2. So if we take away 5 from here, we get minus 2. Now that obviously doesn't work, so we'll ignore it. If you take away 5 from this guess, you get 1 apple left and 2 pears, and bang, that's 1 to 2. Twice as many pears as apples. So this must have been the correct one, and we had started with 8 fruits in total. We took away 5 apples to get a ratio of 1 to 2, and we're already done. Question 20, really lovely question this. You see this all the time. If you had practiced for Maths Challenge, you'd have seen questions like this. What you do is you just assume that the first person is telling the truth, and then you run with it and see what happens. So let's assume Pam is telling the truth. That means Quinton is lying, because Pam is telling the truth, so he's lying. So you've got one person telling the truth, one person lying. This person is also lying because Pam is telling the truth. This person is also lying because Pam is telling the truth. And this person is also lying because everyone is lying except for Pam. She's the only one telling the truth, whereas he's saying everyone is. So if Pam is telling the truth, everyone else is lying. So there's only one person telling the truth. And actually, you can go through it the other ways if you want. You can say, okay, Pam's lying, so Quinton's telling the truth, but then these people end up lying, and it always ends up being one person. It never changes, and that's the way that we do it. 21. 2 lists of numbers are shown below. She wants to move one number from this list and put it in this list, and vice versa, so that the sum of the numbers in each list is the same. So okay, the obvious thing to do is work out the sum of each list now, and the sum of each list is this. So they differ by 6. Now the mistake that it might be obvious to make here is that means you don't want to change out 2 numbers that are 6 apart. For example, I do not want to swap out, I can't even find any, I do not want to swap out this 5 and this 11, just because they're 6 apart and the total is 6 apart. Because if you replace this 11 with a 5, you decrease this list by 6, which will make it 48 in total. But you also, by replacing this with 11, increase this list by 6, and you end up with 54, and then they still don't match. So actually, what you want to do is decrease this list by 3 to make it 51, and increase this list by 3 to also make it 51. So we're looking to swap 2 numbers with a difference of 3. So if we swap the 2 and the 5, then that's great. we swap the 2 and the 5, that's all I was saying. So if the 2 goes here, this goes down by 3, and if the 5 goes here, that goes up by 3, they both get to 51. If we swap the 5 and the 8, exactly the same, and if we also swap the 10 and the 13, that will also work. So there are 3 lists, 3 pairs that will do it. There are no more that differ by 3. We can't differ by 3 in the other direction, because then we make this one bigger and this one smaller, which doesn't work. And so that's pretty much it. Triangular prism is cut out of this thing with corners T to U to V and Q. So this triangular prism is going to be removed to create this shape with a flat diagonal face here. How many edges does the remaining shape have? Well, just count them. Just count them. 1, 2, 3 at the top. 1, 2, 3, 4, 5 around the middle, and then 1, 2, 3, 4 on the bottom. That's going to be 12 in total. It's also kind of interesting that when you look at the original shape, when you cut out that triangular prism, you removed 3 edges, these 3 here, but you just put in 3 edges in the first place here. So you have the same number of edges you did to start with. So this clearly has 12 edges, 4, 4, and 4. So the answer also has 12. Question 23. So I didn't really know how to do the question without using decimal multipliers, which you may or may not have seen. But to increase a thing by 5%, you times by 1.05, and to decrease by 20, you times by 0.8. If you've seen decimal multipliers, then great. If you haven't, I'm sorry, I'm not going to be immense amount of use to you on this question. I can't really see any other way of doing it. But okay, so we take a train ticket, which is called X. We increase by 1.05, so times by 1.05, and then we times by 0.8 to decrease by 20. And that equals 4 less than the original price, so X minus 4. And we just need to solve this equation. Now, you don't have a calculator. You could multiply these decimals by just multiplying 8 times 105 and then move the points back. And actually, thinking about it, that's almost certainly a much better thing than what I did. Yeah, that's better. Just do 8 times 105, which is 8 times 100, plus 5 times 8, which is 840. And then move the decimal points back. That's so much smarter. Anyway, what I did was I turned it to fractions. So this is clearly 8/10 or 4/5 or whatever. This is 105 over 100, which simplifies to 21 over 20. And then I just multiplied these fractions along. And then I said, okay, what happens if I take away this many x's from both sides and add 4 to both sides? Actually, I simplified this first because I like having it over 100. Then I added 4 to both sides and took away this. And 100 over 100x minus 84 over 100x is 16 over 100, times everything by 100, divide by 16, and 400 divided by... Okay, so halve both of these to get 200 over 8, and then halve again to get 100 over 4. 100 divided by 4 is 25. I think working with decimals would have been easier. I also can't see any other way of doing this question other than breaking out the algebra, so apologies. But it's question 23, so it's going to be tough either way. This question was much nicer, a very standard GCSE question actually, not too much maths challengey about it really. You've got flowers in these colours. Purple to yellow is 1 to 2, yellow to red is 3 to 4, red to white is 5 to 6. Our aim here is to make all of these co-numbers match. So I don't want yellow having a 2-part here and a 3-part here. I want them to match. So if I times this one by 3 and 3 to make it the ratio 3 to 6, and then times this one by 2 and 2 to make it 6 to 8, this is still the same ratio as this, of course, and this is still the same ratio as this. But now I can say purple to yellow to red is 3 to 6 to 8. Like it's the same ratio. It's 3 to 6 to 8 because these numbers match. And so now I'm going to make these numbers match by timesing this ratio up by 8 to get 40 to 48, and this ratio up by 5 to get 15, well, to get 30 to 40. So now these 3 things are in ratio 30 to 40 to 8. But I can just multiply this purple one up as well to 15 because I just need to multiply by 5 here and 5 here. And so I get the ratio 15 to 30 to 40 to 48. And now flowers have to be whole numbers. So the least number I can have is just 15 of these, 30 of these, 40 of these, 48 of these, because there's nothing I can divide this ratio down by to get it any smaller. So just add the numbers up and you get the answer 133. The last question is actually not too bad. I think if you had just skipped to it and given it some thought, I think a lot of people would have gotten it. Because actually, you just need 5 numbers here to add up to 17. So just try something. Like here's 5 numbers that add to 17. And then just keep adding them up. So these 2 add up to make 9, these 2 add up to make 7, These two add up to make 6. Now, already I can see that I have done a poor job here, because 6 plus 7 is 13, not 16. So I need to increase... Sorry, 6 plus 7 is 13, not 16. So I need to increase these by 3. How on earth did I do that? Oh yeah, sure. So I said, okay, what if this was a 4? And what if that was a 4? Because that would make 8 and 8, and 8 and 8 definitely add up to 16. Now, I've increased this one by 1 and this one by 1. So notice how I decreased that one by 2, because I still need the bottom row to add up to 17. So make that one bigger by 1, that one bigger by 1, that one goes down by 2. Just leaving the others the same, just because why not? And now I get this, which works for this box, so I'll keep going. 6 plus 8 is 14, that's 15, that's 30, that's 31, and actually it works straight away. And the answer in the question mark box is 4. Now there are hundreds, I would assume. Maybe it will be a really interesting maths exercise to work out how many different combinations work to do this, but what always happens is that this is always a 4. And the fact that I've just found even one of them that is a 4 means the answer is 4. Because if it could be something else, then this question couldn't work. Like if you could find a situation where the answer is 5, then this question doesn't make any sense, because it could be either of them. But the fact that I found one with a 4 means the answer is just 4. Now that's probably not the way that they intended you to do it. Having done this a few times though, like I said, that only took one change. Like I guessed that and then immediately changed it to this, and it just immediately worked. I've done that a few times and it seems to work very quickly whenever I do it. So it really doesn't seem to be that hard. The way that they intended you to do it was just, I think, to call all these A, B, C, D, and E and say A plus B plus C plus D plus E is 17, based on the question. And then this box is A plus B, this one is B plus C, this is C plus D, this is D plus E, based on the rules of the game. And so this one is A plus B plus B plus C, which is A plus 2B plus C. This one is B plus C plus C plus D, which is B plus 2C plus D, which we know is 16. And likewise for this, and then we keep going up. A plus 2B plus C plus B, which makes 3B, plus another 2C, which makes 3C, plus D is D, and likewise here. And then we add these two up, and we end up with this. By the way, if you notice these coefficients, 1, 3, 3, 1, 1, 4, 6, 4, 1, hopefully you spot something. If you don't know what the word coefficient means, or you don't spot anything, that's because you just haven't done that bit of maths yet, but there's some really interesting maths going on there. So we end up with these three equations, which look like a mess, but I noticed that if I just do this one, take away this one, the E's and the A's go away, and I end up with this, and this take away, this is this. And then I'm like, okay, well all I want is C. I don't care what the others are. And I've already actually said there seems to be hundreds of solutions to this, so it seems like all the other numbers can change, but I just want to know what C is. If you look at this one, it's kind of similar to this one, 1, 2, 1, 3, 5, 3. If you just times this one by 3, you get this. And then if you do this one, take away this one, these go away, and you're just left with C equals 4, which is going to be the answer. So that's just a quick little proof that C has to be 4, and the others seem to be, you can just make them largely whatever you want, and eventually it will work. But C has to be 4. Anyway, thank you so much for watching, and I hope that helped you out with your either having done the Junior Math Challenge maybe last week, or doing the future one, this time a year after this video has been published, maybe.